Download this code from codegive.com, link in the description below. Poly, your comprehensive guide to resilience in .NET applications. Poly is a powerful and versatile .NET resilience and transient fault handling library. It allows you to express retry, circuit breaker, timeout, and other resilience strategies in a fluent and composable manner. This tutorial will guide you through understanding Poly, its core concepts, and how to implement it effectively with code examples. Why Poly? In distributed systems, transient faults, temporary interruptions in service, are common. These can be due to network hiccups, temporary server overload, or other environmental issues. Without proper handling, these faults can lead to application crashes, data corruption, and a poor user experience. Poly provides a clean and robust way to handle these issues by abstraction separating resilience logic from your core application code, improving maintainability and testability. Composition allowing you to combine multiple resilience strategies to create sophisticated handling patterns. Readability using a fluent API that makes your resilience logic easy to understand. Extensibility providing hooks for logging, monitoring, and customization. Core concepts. Before diving into the code, let's understand the fundamental concepts in Poly. Policies the heart of Poly. A policy represents a specific resilience strategy, such as retry, circuit breaker, timeout, fallback, cache, or bulkheads. Policy wrap allows you to combine multiple policies into a single, composable unit, creating a layered approach to resilience. Execute actions the execute methods, example execute and capture, execute async, are used to wrap your code that might be susceptible to transient faults. Handles define the types of exceptions or results that should trigger the policy. For instance, you might want to retry only on HTTP request exception with a specific status code. Context provides a way to pass information to and from your policies. This can be useful for logging, correlation, or dynamically adjusting policy behavior. Delegates Poly uses delegates, like func and action, to define the code that the policies will execute and to provide handlers for events, example on retry, on break, on half open. Getting started, installation. First, install the Poly NuGet package. You might also want to install specific extension packages depending on your needs, such as poly.extensions.http, provides helpful extensions for working with HTTP client in ASP.NET Core. Poly.contribution.wait-and-retry, offers more advanced wait and retry strategies, including jitter. Basic retry policy. Let's start with a simple retry policy that retries 3 times if an exception occurs. Explanation *. 1 policy.handle HTTP request exception, this defines the type of exception that the policy will handle. In this case, it's HTTP request exception, which is common when dealing with network requests. You can handle multiple exception types by chaining handle exception type calls or using handle result for return values. 2. Retry async, 3, exception, retry count, equals, this configures the retry behavior. 3, specifies the number of retry attempts. Exception, retry count, equals, this is an on-retry delegate. It's executed before each retry attempt. The exception parameter contains the exception that triggered the retry, and retry count indicates the current retry number. It's a good place to log information about the retry. 3. Retry policy. Execute async, async, equals, this executes the code that you want to protect with the retry policy. The async, equals, is a delegate that represents the operation to be performed. 4. Simulated unreliable operation. The unreliable operation simulates a call that sometimes fails to demonstrate the retry mechanism. 5. Try, catch. The try, catch block catches any exceptions that are thrown after all retry attempts have been exhausted. Retry with wait and retry, exponential backoff. A more sophisticated retry strategy involves waiting between retry attempts. Exponential backoff is a common approach, where the wait time increases with each attempt. This prevents overwhelming the failing service. Explanation asterisk. 1. Wait and retry async. 3. Retry attempt equals time span. From seconds, math.pow. 2. Retry attempt. Asterisk 3, still specifies the number of retries. Asterisk retry attempt equals time span. From seconds, math.pow. 2. Retry attempt. This is a function that calculates the wait time for each retry attempt. In this example, it uses exponential backoff, starting with 2 seconds, 2 sup 1 slash sup, then 4 seconds, 2 sup 2 slash sup, and finally 8 seconds, 2 sup 3 slash sup. Asterisk, exception, time span, retry count, context, equals, this is the onRetry delegate, which now receives the time span, the wait time, and a context object. The context allows you to pass data related to the operation throughout the policy. To new context, my operation, a context object is created and passed to the execute async method. The context can be used to store information relevant to the operation, example an operation ID, user ID, etc. 3. Context in the onRetry delegate. The onRetry delegate now has access to the context which can be used for logging or other purposes related to the specific operation. Circuit breaker policy. The circuit breaker pattern prevents an application from repeatedly trying to execute an operation that is likely to fail. It acts like an electrical circuit breaker. When the error rate exceeds a threshold, the circuit breaks, and subsequent calls are short-circuited, immediately fail, for a period of time. This gives the failing service time to recover. After the break duration, the circuit breaker enters a half-open state, allowing a single test call to see if the service is now healthy. If the test call succeeds, the circuit is closed, normal operation resumes. Explanation asterisk. 1. Circuit breaker async. 2. Time span. From seconds, 30, this configures the circuit breaker. Asterisk 2, the number of exceptions that must occur before the circuit breaks. Asterisk time span. From seconds, 30, the duration that the circuit remains broken. Asterisk on break, an event handler that is executed when the circuit breaks. Asterisk on reset, an event handler that is executed when the circuit closes, resets. Asterisk on half open, an event handler that is executed when the circuit enters the half open state. 2. Broken circuit exception. When the circuit is broken, Poly throws a broken circuit exception. Your code should catch this exception and handle it appropriately, example log the error, display a user-friendly message. 3. Loop asterisk. The loop simulates multiple calls to the unreliable operation. You'll observe the circuit breaker opening and closing as the operation succeeds and fails. Timeout policy. A timeout policy prevents operations from running indefinitely. If an operation exceeds the specified timeout, Poly throws a timeout rejected exception or, when using a more aggressive cancellation strategy, a task cancelled exception. Explanation asterisk. 1. Timeout async. timespan.from seconds, 5, timeout strategy. Optimistic. Asterisk timespan.from seconds, 5, sets the timeout duration to 5 seconds. Asterisk timeout strategy. Optimistic, indicates that Poly should use a cancellation token to try to cancel the operation gracefully. This requires that your code that you're protecting with the timeout policy correctly handles cancellation tokens. The alternate strategy is timeout strategy. Pessimistic, which will hard interrupt the execution. Asterisk on timeout async, an event handler that is executed when the timeout occurs. 2. Timeout rejected exception, Poly throws a timeout rejected exception when the timeout is reached. You should catch this exception and handle it accordingly. If using timeout strategy. Optimistic, you might also encounter task cancelled exception depending on how your task handles cancellation. 3. Cancellation token support, important when using timeout strategy. Optimistic, it's crucial that your code that is being protected by the timeout policy accepts a cancellation token and checks for cancellation requests. If your code doesn't support cancellation tokens, the timeout policy will not be effective, and the operation may continue to run even after the timeout has elapsed. If your code cannot support a cancellation token, consider timeout strategy. Pessimistic, but be aware that this strategy can be more disruptive to running code. Fallback policy. A fallback policy defines an alternative action to take when an operation fails, throws an exception, or returns an undesirable result. This can prevent cascading failures and provide a better user experience. Explanation asterisk. 1. Policy HTTP response message. Handle HTTP request exception. This defines the type of exception to handle. Notice we are declaring that this policy will return an HTTP response message. 2. Fallback async, fallback value, on fallback async. Asterisk fallback value, the HTTP response message to return if the operation fails. This is the alternative value that the policy provides. Asterisk on fallback async, an event handler that is executed when the fallback is triggered. This can be used to log information or perform other actions. The outcome parameter contains information about the original operation's result, including any exception. 3. Execute async, the returned response will be the HTTP response message returned by the unreliable operation if it succeeds, or the fallback value if the policy handles an exception. Policy wrap, combining policies. Policy wrapping allows you to combine multiple policies into a single, composable unit. This is a powerful way to create layered resilience strategies. For example, you might want to combine a retry policy with a circuit breaker policy. Explanation asterisk. 1. Policy.wrap async, timeout policy, circuit breaker policy, retry policy. This wraps the policies in the specified order. The order is important. Asterisk timeout policy, outermost. This ensures that operations don't run indefinitely, even if the retry or circuit breaker policies are active. Asterisk circuit breaker policy, middle. This prevents repeated calls to a failing service, providing it with time to recover. Asterisk retry policy, innermost. This handles transient faults by retrying the operation. 2. Execution flow asterisk. When you execute the policy wrap, the code first goes through the timeout policy, then the circuit breaker, and finally the retry policy. If the retry policy exhausts its retries and the circuit breaker is open, a broken circuit exception will be thrown. If the timeout policy triggers, timeout rejected exception will be thrown. Handling results, not just exceptions. Poly can also handle results. This is useful when you want to retry or apply other policies based on the value returned by a function, rather than just exceptions. Explanation asterisk. 1 Policy HTTP response message. Handle result, response equals response. Status code equals system.net. HTTP status code. Internal server error. Asterisk policy HTTP response message specifies that the policy will handle results of type HTTP response message. Asterisk handle result specifies a predicate that determines whether the policy should be triggered based on the result. In this case, it retries if the status code is 500, internal server error. Integrating with HTTP client, ASP.NET Core. Poly integrates very well with HTTP client in ASP.NET Core using the poly.extensions.http package. This package provides convenient extension methods for configuring resilience policies directly within your HTTP client configuration. 1. Install the package asterisk. 2. Configure HTTP client in startup.cs, or program.cs in .NET 6+. 3. Use the HTTP client in your code asterisk. Explanation asterisk. Asterisk services. Add HTTP client, my HTTP client, registers an HTTP client with the name my HTTP client. You can then inject iHTTP client factory into your services and use the create client method to get an instance of the configured HTTP client. Asterisk. Add policy handler, get retry policy, adds the retry policy to the HTTP client pipeline. Asterisk. Add policy handler, get circuit breaker policy, adds the circuit breaker policy to the HTTP client pipeline. Asterisk. HTTP policy extensions. Handle transient HTTP error. This is a convenience method that handles common transient HTTP errors, 408 request timeout, 5xx server errors, and network failures. Asterisk. Or result, message equals message status code equals system.net. HTTP status code. Not found. This is combined with handle transient HTTP errors, so the retry policy will be triggered if those errors or 404 is returned. Best practices and considerations. Asterisk logging. Asterisk log retry attempts, circuit breaker events, and timeout events. This will help you diagnose and troubleshoot issues. Asterisk configuration. Asterisk use configuration files, example app settings.json, to store policy settings, retry counts, wait times, break durations. This allows you to change the behavior of your policies without recompiling your code. Asterisk context. Asterisk use the context object to pass relevant information to your policies. Asterisk idempotency. Asterisk ensure that your operations are idempotent, can be executed multiple times without causing unintended side effects. This is particularly important when using retry policies. Asterisk monitoring. Asterisk monitor the performance of your policies. Track the number of retries, circuit breaker open/close events, and timeout events. This will help you identify potential problems and optimize your resilience strategies. Asterisk understand your dependencies. Asterisk different dependencies, e.g. database calls, external services, have different characteristics. Tailor your retry strategies and thresholds to the specific dependency. Asterisk combine strategies. Asterisk don't rely on just one resilience strategy. Combine retry, circuit breaker, timeout, and fallback policies to create a robust and layered approach. Conclusion. Poly is an invaluable tool for building resilient .NET applications. By understanding its core concepts and implementing appropriate policies, you can significantly improve the reliability and availability of your applications in the face of transient faults. Remember to tailor your policies to the specific requirements of your application and dependencies. Good luck.